In today's video, we'll be looking at slopes. So slopes measure the steepness of a line segment. And if I were to draw a line segment on this graph, that would look something like this. I could look at the rise and run of this line to calculate the actual steepness or slope of the line. And the rise is a vertical distance between 2 points, and the run is a horizontal distance between 2 points. So all you have to do to calculate the rise and the run of this line is basically make this line a right triangle and draw the vertical line and the horizontal line. So simply put, all you have to do is uh, draw this vertical line here and draw the horizontal line here. So you get your right triangle, and the vertical line of the vertical line of this right triangle is the rise. So the vertical part is the rise. Since the rise is the vertical distance between 2 points, and like I mentioned before, the run is the horizontal distance between 2 points, and that means the run is the horizontal line. So we had our first line segment, and we drew our vertical and horizontal line to construct the right triangle, with the vertical line being the rise and the horizontal line being the run. So now that we have our rise and run, we can look at the numerical values of this rise and this run. And to do that, we must find the endpoints of the coordinates of the endpoints of our line segment. So we have 3, 8 here. That's our first endpoint, and we have negative 4, 6. Sorry, negative 4 and negative 6. So those are our 2 points. And to calculate the numerical value of the rise, it's basically just finding the length of this vertical line. So we could do this by counting the number of spaces, because the scale is just 1 here, but sometimes we don't have a scale of 1 on our graph. And the easiest way to find the length of this line would basically to subtract this coordinate here, our y coordinate here, and our y coordinate here. So that means our rise the rise of this line is equal to 8, our first y coordinate, and this we're going to subtract negative 6. And that gives us 14. So that's our rise, and our run is the same thing. We're basically trying to find the length of this line here, and to do that, we could calculate the number of spaces, but since not all graphs have a scale of 1, we could just subtract 3 and negative 4. So the run is equal to 3 minus negative 4. And that equals 7. So I would just like to clarify if the order you subtract the points matters. So if you do negative 6 minus a and negative 4 minus 3, so the actual order of subtracting the points doesn't matter. You just have to be use the same order for both. So you can pick which coordinates will be the first number. So here, 3 and 8 were the first numbers, but if negative 4 and negative 6 were the first numbers, so if we had something like negative 6 minus 8, we get negative 14, and negative 4 minus 3, which is negative 7. It wouldn't matter because we're just going to end up dividing the rise and the run, and the signs wouldn't change if we did it like this way. So all you have to do is make sure that the order is consistent, and if you're subtracting, if you're starting with this coordinate here, if you're starting with 8 here, then you also have to start with 3 with your run. You can't start with 8 here and then start with -4 here. That doesn't work. So now we have to actually calculate our slope, and I just mentioned here that when you're calculating the slope, you have to divide the rise and the run, and that's what we're going to do in our next step. So we have m, and if you think back to last video, we have uh, m, which is our symbol for uh, our slope, just like in the formula y equals mx plus b. So we have m, which is rise over run, and that gives us our rise, which is 14, divided by a run of 7, and that equals 2. So that means the slope of this line would be 2. So now we will be looking at the slope of this line, and first we must draw in our vertical and horizontal line to make our right triangle and to get our rise and run. So let's do that here. So this is our horizontal line, and our vertical line would be here. So we have our rise here, which is our vertical line. This is our rise. And of course, this is our run here. So now we can calculate the numerical values of our rise and run by looking at our coordinates of our points of this line segment. So we have -8, 8 here. And we have 4, -3 here. That's our second point. So to calculate the first, we calculate our rise, and this would mean that we would have to subtract our y coordinates. So we could do this by taking the coordinates of this point here and using -8 and 8 first rather than 4, -3. So we have 8 minus -3. That's our second y coordinate. So that gives us 11. So that's our rise, and our run is the x coordinates. So it's -8 minus 4, and that gives us -12. So that means uh, m equals rise over run, which is 11 over -12, which is -11 divided by 12. So now we're going to be distinguishing between lines that have positive slopes and lines that have negative slopes. So these are the two lines that we had in this video. The first line was m equals 2, that's positive, and the second line is m equals -11 over 4, so that's negative. And the reason why we have a positive slope and a negative slope is with positive slopes, the line is always rising from left. So you start from the left to the right, and it basically looks like it's going up. But with lines that have negative slopes, like -11 over 4, the line is falling. So it basically looks like it's going down, and it's going down from left to right. So for the positive one, it's going up, and the negative line, the slope with the line with the negative slope is going down. It's falling from left to right. So in the last part of this video, I would like to go over the slopes of horizontal and vertical lines. So the slope of a horizontal line would be 0. And that's because a horizontal line does not rise up or down, and that means the rise of a horizontal line is 0. So if we were to calculate the slope of a horizontal line, m would be rise over run. And like I said, the line doesn't rise up or down, so the rise would just be 0, and the run would be here. So this is -5, 2, and 7, 2. So it would be 0 divided by 12, which should be 0. And I didn't even have to calculate the run in this case. I already know that the rise is 0, so I know if I have 0 as our numerator, we're just going to get 0 for our slope. So that means horizontal lines, since they do not rise up or down, they have a slope of 0. So vertical lines are a bit different. There's no run with vertical lines. We do have a rise because the line could rise up or down, but there's no run. So that means our run would be 0. And if we were to write it out, we'd have m equals rise over run. And our rise would this time would be we could just subtract -7 and -3, which would be -7. And like I said before, there's no run, so that's 0. And this time, since we're dividing by 0, we get undefined. And that's because when you divide by 0, there's no number to really represent 0, so we just write it as undefined, and that's the slope of a vertical line. So the slope of a horizontal line is 0 because there is no rise. It doesn't rise up or down, it's flat, but there is a run, so it's just 0. And with vertical lines, this time we do have a rise. It can rise up or down, but there's no run. We don't have a run, and that means run is 0, and we're dividing by 0, so the slope of this line is undefined. So I hope you enjoyed today's video about slopes and learned something new. In our next video, we will be looking at the formula for calculating slopes. So this time we looked at rise over run. There's actually a formula we could also use to calculate slopes. So stay tuned for then. And if you have any questions, please leave them in the comment section below. And if you want to see more videos like this, please subscribe to this channel. Thank you.